Welcome back. In this lesson, we're going to look back at conservation of energy. Is it possible that we can take a little bit of limited resource and make it stretch as long as possible? Can we be smart about how we use? Can we develop technologies that allow the same amount of energy to do more? And can we limit what we do? Can we change the way we think in order to make the energy last even for our children or our grandchildren? So let's look at some examples. To conserve means to take care of, or to keep it, or to guard it. And we want it to last as long as we can for as many people who would need it. And so conservation is just as important as research in trying to find new energy sources that we might not be in a crisis. So the first, of course, that we use the most of is petroleum, and then we use coal also in power plants, and natural gas. Natural gas is actually on the uprise. Lots has been found in the United States, and so it's being used more and more. Coal less and less. Oil is found more in the United States, and we're less reliant on it in terms of the Middle East. So in some ways we're safer in that respect as a country, but we still are talking about a non-renewable resource. And so we're going to see that the United States and the rich countries are actually using a lot more non-renewable resources than even the poor developing countries, who are using more of renewable resources. So in terms of conservation, using less, of course, is the number one idea. Also, not squandering it as we produce it. So if we can produce it more efficiently, then that will save. If we can transport it more efficiently, then that will save. And so it's not just the production of, say, the oil or the gas or the coal, but it is how we use it and in what places we use it and how we transport it. All of that is necessary if we're to conserve it and make it last longer. So efficiency is this idea of how much energy can we get out of something for the amount of work we put into it. So if something is efficient, it's going to get more out of the energy than before. So for instance, if you were to warm yourself by burning $100 bills, I suppose you could get heat from that, but the cost of that would be ridiculous because a piece of paper does not gain you a lot of heat, but that piece of paper being worth $100 a piece is going to be a squander of your resources. Likewise, if you take a ton of coal but only get a little bit of heat out of it, you're burning a ton of coal that a lot of energy is in, but you're getting only a little bit out. Then your lack of efficiency is actually wasting that energy resource. So if you can, a penny saved is a penny earned. If you can make it more efficient so that you're getting more energy out of every gallon of gas or every ton of coal that you burn, then that's the same as if you had more of it. All right, so as you improve the efficiency of your industries, as you have more efficient power plants, more efficient generators, more efficient furnaces, more efficient automobiles, then it's the same as having more energy. Because if you can go the same mileage on 1 gallon of gas as you used to go for 30 gallons of gas, then it's the same as having 30 extra gallons of gas per car. So the technology then is something that's important. Can you develop a technology to where you can get more bang out of your buck? And that's the idea. So in terms of efficiency in transportation, putting more people into one automobile is more efficient. So if you lived in a densely populated city, everyone taking the train, okay, so hundreds of people riding one train, and that one train, instead of hundreds of different cars, one train is going to use less energy than 100 different cars. buses will be more efficient than all the cars. Now, also, if the most efficient machine that mankind's ever produced is a bicycle, you're getting, for the cornflakes that you eat in the morning, you can get about 90%, 6 or something like that, percent of the energy from your food into your muscles and into that bicycle to take you somewhere. So a bicycle is actually a great idea. Now, in a rural place that doesn't have access to bike lanes and where it's dangerous to walk or to ride a bike, then cars are really your only option, because you have to keep safe. You can't endanger yourself. But in a densely populated city, part of the urban planning is to actually make places for bicycles to be, or walkers, or whatever. If you can be sneaky about it, it is very possible that you could, for the energy that you do use, the coal you burn, the oil you burn, you could do two things at once, okay? So a cogeneration plant is always what you're looking for if possible. So in this case, I've got a schematic here. If you could gain electric energy and thermal energy at the same time using the same source, okay? So for instance, if you're burning coal to make a turbine run, and the turbine is generating electric energy, well, that coal that's burning is also creating heat. If you could then harness that thermal energy along with the electrical energy, then you've done two things for every ton of coal that you've burned, and that's more efficient than otherwise. Sustainable simply means that you can keep going, that it's possible that if you have energy that you can sustain, then it's possible that your children would have energy or your grandchildren would have energy. So as we cooperate together to try to come up with new ideas, then it's possible that even with a limited resource that we have, that it will not go out during our lifetime. We can at least let it go on into future generations.